That was Bowie Pong reporting from National Meteorological Centre earlier. Weather and sea conditions in the southern Indian Ocean continue to impact the progress of the multinational search operations. And for more on the challenges facing the search teams, we're now joined by Professor Simon Boxall from Southampton in Britain, an expert on ocean and earth science at the University of Southampton. Hello there, Mr. Simon. We know the search was called off because of the high waves and the strong winds on Tuesday, but the weather improved on Wednesday and the rescue has been resumed. So give us a picture of how the seas can actually affect the aircraft and ships involved in the search, and also how difficult is it to locate or recover debris in the high seas?
The big problem is that this is one of the most remote parts of our ocean. It's 4 hours away from the nearest landing strip, or any land really, which means that any search aircraft have to fly for 4 hours before they're on site to survey. They get 2 hours on site and then have to fly back again to refuel. Even the ships, it's taken several days for the nearest ships to arrive at this most remote part of our planet. Now the problem is when the weather closes in, and we're going into the Southern Ocean winter now, which means that a high proportion of the time we have very big waves, in excess of 10, 15 meters at times. The visibility, because of low cloud, high winds, rainfall, means that the aircraft can't do any work. It means that they cannot see the sea surface. And what they're searching for to begin with is some sign of wreckage in the ocean at the surface, floating wreckage and debris. The other problem is that this region, that the oceans have a lot of rubbish in them anyway, and trying to separate out from the satellite pictures from the high-level aircraft data what is general rubbish in the ocean and what could come from the Malaysian airline is difficult. We need to send a ship to the location to collect what's at the surface. That's easy once you find it, to then determine has it come from the Boeing 777.
Right, indeed. And in order to understand what exactly happened on the airplane, black box is a very crucial hard evidence. And the battery life is said to be less than 2 weeks long now. If its battery runs out before a signal can be picked up, then what are the odds of finding it under the sea?
The problem is that the bulk of the fuselage, most of the aircraft will be on the seabed. Now, the seabed in this area is 3,500 meters deep. That's over 2 miles deep. So trying to find it on the seabed, and it's not a flat seabed, it's undulating, trying to find it on the seabed is difficult. The black box is sending out an acoustic signal. Radio waves don't work underwater at all. So they're relying on picking up the acoustic signal. But they need to be virtually on top of the plane before they can pick it up. And the search area is enormous. It's tens of thousands of square kilometers. So the chances of the special equipment that's being taken out by the Americans of detecting the black box in this huge search area is unlikely. So they're going to rely on sonar, side-scan sonar, which sweeps the seafloor to build up a picture, a bit like a bat uses sonar sound to build up a picture of what's ahead of it. But it's a very slow process. The ships move slowly by definition, and the area that each sonar beam covers is very, very small. So it could take years before they can actually detect the wreckage on the seabed, even if they get evidence from surface wreckage that this is the correct area to be searching.
All right, thank you very much indeed. Professor Simon Boxall from Southampton in Britain. He's an expert on